Today I will do a very quick review regarding determinant, and if you prefer difficult on difficulty on determinant. Uh, there is a lot of determinant formula that you can calculate it by, which is we use sigma, so sigma j equals to 1 to n, and minus 1 plus j, and aij determinant a1j. When we divide it as more of more determinant and multiply it by element, what you should know is when like a1j plus determinant a1j, then you should exclude the row and columns of what the element is inside the determinant, like argument is inside. You can calculate it very easily in parallel, or in even you go down, you can easily calculate it. And there is cofactor A, which is given byCij's minus 1 I plus j determinant aij, which is very interesting concept, and you can really easily calculate cofactor. If it is if we very carefully if the cofactor, then let's see, minus 1 ij. So if it is in first row, first column, it will be plus sign, but it will be negative sign. The next to it will be negative sign. By this way, you can easily calculate it. The important thing is you should remember that A is given first by aij. And if it is triangular matrix, you can calculate it by diagonal of the matrix, but it is actually very easily induced it from cofactor formula. And there is some determinant properties, which is determinant if you multiple of one row of A is added to another row to produce a matrix B, then determinant B is famous determinant A, which is replacement. And when you do interchange between two rows, which is if two rows of A are interchanged to produce B, then determinant B is K multiple determinant A. And when you scale it, when you scale one row to K, to produce to K, then determinant B will be K multiply determinant of A. You can also, this is very important because there's, you have a lot of case, you should calculate determinant, and in 2x2 cases, you can very easily calculate it, but if it gets bigger, it will be super duper difficult. So then in that case, you can maybe calculate it uh by make it as low echelon form and calculate the determinant by diagonal. But what is important is you should know that how many times you row replacement, or you interchange, or you scaled. It will be very important unless you can't calculate it. And if A is matrix, then determinant AT is determinant A, which is very good property. And also determinant AB can be calculated by multiplying of determinant A and determinant B. It's very nice property what determinant has. And there's a lot of properties what determinant has. Determinant has function, so if you go dive deeper, then there will be a lot of property we should look around. But for today, we will just quickly sum up in properties of determinant. Thank you.